Okay, now that we've gone around the outside, before we go inside the house, this is what we're going to try to have you see. Is that when we walk inside, you're going to notice that we have transfer grills. That allows us to move the air through one room to the other. The whole house is set up to have constant temperature. So if you put the thermostat or if you put a thermometer in any room, the heat and humidity would be the same in any room. What that allows for is that before you have to put energy in the house, all the house is one temperature. So you're not fighting from one room is hotter and the other room is colder. You make it all one temperature first. The house will be basically bulletproof because when you have 6 inches reinforced concrete, it'll pass a 100-mile 2x4 test. So if you're standing behind the wall, you're safe there. You're going to have constant humidity, and it's going to be very comfortable and very quiet. The idea of having a house that has lower humidity, if you can manage that, is that the temperature of the house is more comfortable, but it smells better. It doesn't smell musty. And so the normal owners that you associate with the summertime in hot attics, upstairs, when you can't quite cool your house enough because it's so hot outside because the humidity is too high, it eliminates all that because we've sealed the house from the humidity that causes those problems. The temperature throughout the whole house will be constant. And the last thing we're going to try to look at is that we're actually, once you've done some of the other things as far as enveloping the house and doing the things that actually save you money and create a great space for you, is that we look at the appliances. Because when you look at the appliances and they become more energy efficient, it's worth spending a little bit of extra money that allows you to have the savings from them. Okay, let's go in and take a look. Alright, now we're going to do a tour of the inside of the house. As you can see, regular construction. There's nothing special about the house that you can typically see other than the fact that if you come over here, is that the windowsills are wider. So we're doing concrete wall construction in this climate where we have high wind events. Then this affords you better protection than you could do out of anything you could possibly do out of wood. Say if you look at the windowsills, then you have 2 inches of styrofoam on the inside underneath the drywall, then you have 6 inches of concrete, which is a reinforced monolithic, and then you have 2 inches of styrofoam. What this means is that this wall will pass a 100-mile 2x4 test. Meaning that if they have a projectile, it will not come through the wall. If you're not standing in front of the window, you're safe in the corners. Also, the walls won't blow over from any kind of hurricane or wind event. These are structurally engineered to withstand, because they're only 10 foot high, 200-mile-per-hour wind as long as you have a corner. So that wall should not fail up to a 200-mile-per-hour wind. Other than that, it's regular drywall. The drywall is attached right to the ICF. And this is solid right here, so if you want to hang a picture, we hang our cabinets. You can actually hang a second floor or do some structural issues up to the capacity of where the wall assembly is engineered for. As far as the house, we're doing a floating wood floor here. We have the outside door for the screened-in patio that you saw outside. This is a functional fireplace. This is actually the smallest BTU fireplace that you would want. The house is constructed well enough that with no air conditioning, that this will take the chill off the house. And if we just leave the fans on, when it's 28 degrees outside or 25 degrees outside, this will keep the house comfortable enough for you to be able to stay here. And it's a gas fireplace that comes on. And if you even have no electricity, you can manually light it. But this is a vented fireplace, but the heat, it's 18,000 BTUs. Other than that, again, we have plenty of light in here. This particular room, we have more volume. But the air temperature upstairs, we have a center plenum that comes back, but we try to create a house that is economical to live in, not too large, and efficient. If the utility cost here on the house, if we're able to say that we're only going to use 7,200 kilowatt hours for the whole year, which is where this house is at today's utility rates, it ends up being about 10 cents a kilowatt hour, so that's $720. So we're saying that we're going to average $60 a month for heating and cooling. And I believe that we'll be under that, but that's a very doable, and I won't see that without creating the environment and the shell and the structure to do that, then you can't have that benefit. Kitchen appliances, it's more of a design issue. We made it logical for the homeowners. We have an open space here, but it's not very large. We use just stainless steel appliances. We used a gas oven here. We have a very nice air blower assembly. On this assembly here, we actually bring makeup air, so we're not actually pulling air out of the house and then creating a negative pressure. We're actually bringing in with using an ERV, which is an energy recovery ventilation system. We're actually replacing the air, slightly pressurizing, so when we're taking air out, we're not bringing in unconditioned air. We've already conditioned it. That's a Samsung refrigerator. High efficiency, doesn't use as much energy. You can afford to do that if you're not paying much for utilities. What we did is we put radiant heating in the floor, and we did it strategically. And another place here, but basically we put it just where you walk and where you be comfortable. So we put the radiant heating in the floor where you'll get out of bed. But what was more important is that we can use radiant heating from the mechanical system upstairs, but we can keep the house warm without using strip heat or for the HVAC units. So this house doesn't need strip heat, so when it's 28 degrees outside, we can keep this house warm without using strip heat upstairs part of the HVAC. If you look up there, that particular vent that's on the ceiling over there is more of a commercial vent, but that's the proper vent for a ceiling mount. Most houses don't use a proper vent, but that allows to get the air distribution correctly to all four corners of the room without a lot of velocity. One of the places we emphasize radiant heating is that we put extra radiant heating here, and this floor is warm. So we can keep the floor in here at 80 degrees when the rest of the house is 72. So when you wake up in the morning, you come in for your morning shower, and so this floor is warm. There's a what you call the transfer grill above the door here that allows the air that's pulled out of the bathroom to come back in from the rest of the house. And there's another transfer grill in every room that, as necessary, to allow the air, so if the door's open or shut, it will still allow you to have the right amount of circulation in every room. The whole idea is that you never put energy into a house until you have equalized the temperature throughout the house. So you might have a cold room or a warm room. You might be cooking in the kitchen. So what you'd want to try to do is take the heat and distribute it throughout the house before you put energy in, because you might be in a room that's cooler. So in fact, if you move all the energy, all the air around properly, then it makes the house one temperature. And you never want to put you never want to have your air conditioning system on until you've equalized the house. Many houses that you live in is that one thermostat will work against the other one, meaning that at certain times of the year or certain parts of the day, that room will be warmer, so the thermostat will call for heating and cooling, and another section of the house doesn't need it. And if you're not paying attention to the air distribution system to equalize that, then you're wasting energy. Let's go upstairs. We've done enough down here. Okay, another interesting thing as far as design issue is that we put a switch for little LED lights so you don't have to turn the lights on, and you can just leave them on if you have guests here. This house is really designed for the people to live downstairs, and when people come to visit, then they can go upstairs. But if you leave this light on, it has less likely to be leaving lights on and turning the lights on and off as much as you might. With a concrete house and all the exterior walls here are pretty much projectile proof, but with impact windows, the impact windows will still break, but there's no cost advantage for energy or reduction of utility cost. And in fact, if an impact window breaks, it costs you a lot more to replace it. So on this house, we use a DP50 window, which is very durable for a wind load, but we have a very low U factor. The windows in this house have a U factor of 0.28 and a solar heat gain factor of 0.31. And the impact glass can barely meet that, but in fact, if you just put an energy shield on there, you can have all the value of impact windows without the true cost and still do have the protection that you would need. If you were here standing with me, I would say, and this would be kind of a challenge, we have a single air distribution system here, a single air conditioner, and that this room is the same temperature as downstairs. So if I take my little AccuThermometer, thermometer, which I think I have one, yes I do. If I take my AccuThermometer, thermometer, then I have the thermostat set up here at 77, but I'm 77 degrees up here, 67 degree humidity. Downstairs was 76 on the thermostat. So we're basically keeping the upstairs and the downstairs the same temperature, which is only to signify that we have enough air distribution coming through the house that this room has more of a load than downstairs, but I'm moving enough air through here to keep it comfortable. One of the struggles that everybody has is, well, how much does it cost? Well, the fact is we have an energy recovery unit here that filters the air, brings in more fresh air, allergen-free. So if you have allergies, then we're bringing in fresh air, which is better than opening your window, but we're actually recovering and lowering the amount of humidity that comes in the house, but bringing in more fresh air is the same as if you had a window open. But when it's 90 degrees outside, it'd be difficult to have a window open because then you're going to lose your dehumidification. Okay, now we just walked through the house and saw all the great things that are possible in the house. They're all simple, they're all doable, and they're all using just basic automotive technology. There's nothing special about it. What's special about it is actually how we pull it together and make it useful all as one system. You would always want to think that the house is a single system, and so you want to treat it that way. And let's go on to the next video and we'll have some fun again.